And now, without any further ado, we're going to turn it over to the evening entertainment. He's going to pull out his crystal ball, and we are going to look into the future of home building. So please, let's give a warm welcome to the inimitable Peter Yost.
Great to be here. Welcome, everybody. This is my company, Peter Yost Building Right. I left Building Green January 1st, and pretty involved with Green Building Advisor and Fine Homebuilding. And we're going to talk about what the industry is going to look like in 2039. And so it's a lot about how do we build, what do we build with? And it's going to be kind of a free-for-all of sorts. This is part of the problem. Some of you, maybe many of you, know me as the WINGNUT on Green Building Advisor. It's to do testing of materials because, as John Straub once said, ASTM does not stand for the American Society of Testing Materials. It stands for another stupid test method. So I do a lot of field testing of building materials, but that's not why I'm here. I'm here because I'm a soothsayer.
Petey, you're a great guy, but telling us the future, man, don't see it. By the way, nice picture.
Yeah. So for those of you who don't know, that's Steve Basic, and
He was your friend.
well, we're getting pretty close because this is the problem with asking somebody to come in and talk to you about the future when you can see that this is a graph of the cost of fuel oil, particularly in New England, and
Specifically Vermont.
yeah, and so what did I do? I bought a year's worth of oil when it was $4.78 a gallon.
Like I said, some soothsayer. We're supposed to listen to you. Right?
Yeah. So there's a real problem with trying to predict the future, which is, particularly in today's world, it's pretty tough to do. But they asked me to give it a whirl, so I am. And that's for the love, Steve. Right? So
Many moons ago.
Steve and I and my brother Nathan had a company called 3D Building Solutions. So I've just now learned that he is a former business partner and apparently a former friend as well. I don't expect that's the last time we're going to hear from Steve Basic during this presentation. So I'm going to go through, and I did some research, right? Because if you want to find out what's happening in the world or in the industry, you have to do a little bit of work to figure out what people have said, other than just yourself. So one of the things is increased mechanization. So I was a full-time builder remodeler. It was quite a while ago, but I distinctly remember the first time I used the drywall lift, and I thought, holy crap. I'm both really happy to find this, but I'm also really pissed off for all the times I lifted the drywall to the ceiling rather than using, it's mechanization, right? It's improvement. A lot less labor involved with this. And then, a couple years ago, I used the first lift for the first time, right? Totally changes the way you work. No more setting up boxes, no more ladders, no more pump staging. You know, when you get up on a lift like that, you can have your entire shop up there with you. And it's just amazing. And this is common. It used to be pretty rare to see lifts on job sites, but it's mechanization. But that's not really what we're talking about, because we're not talking about today or tomorrow. We're talking about 2039. So this is a company out of Perth, Australia, FBR. They started in 1994 to work on how to lay any type of masonry with a computer. And their latest version is this one here, Hadrian X, which does just that. And it is Perth, Australia. Like, what the hell does it have to do with us here in New England? But there's a particular reason why they've been working on this since 1994, which we'll get to in just a moment. But highly mechanized and can lay out an entire building strictly from robotics, which are mechanical systems driven by computers. So robotics also can involve a 3D printer. So I don't know if you're familiar with this company, Icon. but that's a iPad driving a 3D printer for a cement slurry. You can say, holy crap, where are they going to build that? Well, it turns out that's Austin, Texas. And that was the first permitted home built with a 3D printer. Now, we could have a lot of discussion about the building science of these types of construction, and we will, but in milder climates, these systems are taking hold. So we got concrete and masonry, blocks. What about in steel? Well, this company, SHG, Heim, uses structural steel with this type of an assembly system, an awful lot like an automobile, and they build homes that look like this. This is in central Thailand. Also probably not terribly relevant to New England, but totally driven by robots, and there's a reason for this. A little bit closer to home, how many people are familiar with Blueprint? So this is a company out of Baltimore, and you send them your plans or your architect's plans, and they drive it through their factory process and deliver a final product to the job site that's sort of panelized. You have a highly trained crew build it, but then they come back at the end to basically wire and plumb the entire house. So they're involved really substantially at the beginning of the process in a giant factory in Baltimore, but then they come back and complete the process with quality driving this. This is all about what can happen in a factory as compared to what happens on job sites. And I'm showing this slide because when you go to projects on their website, they're all zip projects. So that's kind of interesting because as a system-built company, they went looking for a system-built exterior wall system. Now, full disclosure, I do a lot of work for Huber. And so I called them and I said, hey, you guys are involved with Blueprint. And there was some hesitation. They said, yeah, but one of the advantages of a plant like ours that does continuous board generation is we can cut them to any length we want. The problem is that if the plans don't come from within Blueprint, but they're coming from people and architects all over the place, they're not modularized plans, right? So they're asking Huber for all these incredibly esoteric lengths, which sort of defeats the whole purpose of being in a factory, right? So we have had modular and panelized homes for over 50 years, right? In central Pennsylvania, there have been companies doing modular, and one of the big problems is how do you create something that's modular but also has a custom feel to it? And I think there's an inherent problem with people who are used to site-built construction driving the decision-making process about how to move to robotic systems or to modular. So that brings us to the next thing, which is, well, wait a minute. Are there people who really know how to do factory production that are involved in home building? Well, Toyota has been building homes since 1975. In fact, some of their first locations in the US that sold homes, they sold them out of their automobile showrooms, right? Apparently not terribly successfully, but they know how to drive a process where you modularize everything, right? You create systems within a factory that give you the units you need, and then you plop them together. And again, we can have a discussion about the building science here, but this is where we're moving, and there's got to be a driver for it. Honda builds homes in the US. They're taking a slightly different approach. They took this is Davis, California. Anybody familiar with the Honda Smart Home? And they're sort of going the opposite way of Toyota. They're taking their system of production and trying to figure out how to fit it with site-built construction. So it's sort of the reverse approach that Toyota is taking. And here's the house that they've built. Tons of research. I have a little bit of a question here about their architect and the water management right about there. And these pop-outs are also sort of willy-nilly. I'm not an architect, but I expected Steve to jump out of his skin when he saw these. But the other big thing is the battery systems in cars we know are going to be connected to the battery systems in the house, and we're going to have this connection between the battery systems and the vehicle and the home in a way we've never had before. And there's a guy named Michael Koenig. I don't know if any of you know his name, but he's the head honcho at Honda Smart Home. And he's been at Joe Stiebrick's summer camp. He's been working really hard to try to figure out how to move these buildings from climate to climate. Because that's the other thing, is you can move cars from climate to climate. But I mean, you think about it, pick the sort of the cheapest car you can imagine. I have a favorite. Chevy Spark. Anybody ever driven a Chevy Spark? Yeah, so if I had a 7-year-old Chevy Spark and I drove it in a rainstorm at 70 miles per hour, would the car leak? And probably not. So the least expensive car, 7 years old, doesn't leak water. We can't build houses that sit still that don't leak water, right? So you're sitting in the car, and if it's an old enough car, you're cranking down the window, or if it's a new enough car, you're pushing a button. And do you ever have to worry about the water management of your car door and its window? I mean, the water must get in there somehow, but how much water gets in and where does it go? Well, they have tuned how they use sealants and gaskets for every application inside that car. So that door does leak. It just doesn't leak into your car. It's got weep holes at the bottom, and then gaskets are used to control. So one of the big differences between site-built construction and production is going to be when to use sealants, when to use adhesives, and when to use gaskets. Because we don't do as much. We use gaskets in windows, but we kind of confine it to that. Here's what's going to drive this. So this is the Bureau of Labor Statistics, and these numbers are in thousands. So these are the age cohorts. So 16 years and over, 16 to 19, right? So look what happened. Look at this huge bulge right here, right? There's nothing in the pipeline, right? So you're experiencing this in your jobs, certainly up in Vermont. We can't find workers, but even better than that, if we're going to be building high-performance structures, you can't just pull anybody off the street. They've got to have a certain amount of training. So not only do we not have the workers, we don't have the type of workers that we need, right? So this is a huge problem, that we just don't have. The median age for across all construction is 42.5. That's not a recipe. That is a recipe for robotics, right? Because that's how we're going to get them built. This is from NAHB, Ion Housing. These are different construction trades. This is the median age. Electricians, 40. Masons, 41. Plumbers, 42. Carpenters, 42. Site supers, 47. And inspectors, it doesn't matter if it's a building inspector or any type of inspector, 52. And nothing coming up in the pipeline. Here's the real tragedy, is that even in the high-paying trade jobs on the commercial side of our business, we don't have anybody going into those programs. All the kids are going into college because that's where they think the money is. So this fellow right here, who is kind of the focus of this article, he is making $62,000 a year while he goes to school to raise his income up to $82,000 a year. And yet we don't have people entering the trades, even when they're going to get paid that kind of money. So there's a huge disconnect between the labor that we need and the people that are going into the trades, even when we have really good pay. So that's what's driving this, is that everybody's going to be moving to mechanization because we got to figure out a different way to do it. People aren't interested in coming into the trades, at least not in the numbers that we need. So this is not a big surprise to you. We have all these robotics that are developing inside the home. This is the Roomba, right, which is the vacuum cleaner. This is called Lika. Lika is a interactive computer robot for autistic children. This is Home Patrol. So this unit is connected to your smartphone. So the camera moves based on how you direct it from wherever you are. So it's a moving security system. This is my personal favorite. This is Jun, and Jun is a spiritual advisor who is a robot. I don't know what these people are drinking, but it's better than what we have. But this is where it gets kind of interesting and also a little scary. That's a human heart. Since the 80s, we've been trying to figure out how to make an artificial heart. And this is 2015. This is Steve Williams. He doesn't have a heart. He's wearing the backpack that powers the pump that's installed in the middle of his chest. And right now, these artificial hearts are an interim solution for people who can't get a transplant. So he's living on, he himself, it's a really interesting article about this fellow because he should have been dead 3 or 4 times over. But he actually has had a heart transplant, but it was after 6 to 8 months, I forget exactly how long, where he was working with this heart that weighed about 3 or 4 times greater than a human heart, and that was powered by a compressor pump, essentially, that was moving it through his body. Now, so well, that's a little bit extreme. Probably all of us know someone, or don't know them, but have contact with somebody who has valve replacement, right? And that valve, if that person doesn't die of a heart attack, when they die, they have to turn it off because it just keeps pumping blood, right? So we're moving into a stage where it's not just the robotics on the outside, it's the robotics on the inside. You can say, well, what the hell does that have to do with where home building is going? So this is my friend Jim Ewing here. I used to teach a class when I taught high school called Outdoor Learning, and he was one of my students. I taught him how to rock climb, and then he went on to be a really accomplished climber, became an engineer for Sterling Rope, which is up in Portland, Maine. And that's Larry Hamilton, who was sort of a mentor to both of us. Jim was climbing 2 years ago in the Grand Cayman Islands. His daughter, who was 13 at the time, was belaying him, and he fell. And he fell 3 times, but the last time he hit the ground, and that was about a 50-foot drop. So he punctured a lung, he broke his pelvis, he shattered his left leg, and he broke his right wrist. And it was a miracle that they got him out of the Grand Cayman Island on a medevac helicopter to keep him alive. But here, he's having his left leg amputated, just below the knee. And he's having it amputated because he doesn't have enough function. It's not dead, but it's pretty close to it. And the really interesting about this is that a lot of the work that's being done on robotic prosthetics is out of, you'll see up in the corner, MIT lab. One of the primary drivers of robotics for human parts is a guy named Hugh Herr. Does anybody recognize that name who might be in the building community? Hugh Herr was a cocky Western climber who came to New England, went up on Mount Washington because it was only 6,288 feet, proceeded to get lost in the winter and lost both of his feet to frostbite. And Albert Dow, who was a climbing instructor in North Conway, died in an avalanche looking for Hugh Herr. So the climbing community has a very kind of torn thing about Hugh Herr. Hugh Herr went on to become an engineer at MIT and did some of the first work on the prosthetic that Jim's going to be accepted. But here's the really cool thing. When they cut his leg off below the knee, they took all of the tendons, the muscles, and the nerves and tied them together just below the place where he was amputated. And it's called the Ewing amputation. after Jim Ewing. And it's called the agonist-antagonist myoneural interface. And what that means is that they took all the muscles and nerves that push and pull at different times to move every part of your ankle and your foot. So I'm going to show you this video. So I just want to show you this little ditty on the side. Jim's got a roll of tape stuck on the bottom of his foot, and he shakes it off just like you would. And that's all because they were able to take all those nerves, tendons, and muscles and connect them to a bionic leg underneath. Jim can walk with his eyes closed because he feels through those nerves where his foot is, right? This is really going to change everything about the way that we use robotics. This is Marine Corps Captain Derek Herrera. A sniper bullet hit him and he lost, he was a paraplegic. Rewalk is a whole system of external robotics that mean that he can walk. Now, he doesn't have the neural sensation, but there are different techniques that are going to be merging together in terms of working on moving parts that are on the inside and on the outside. And so one of the things here is that people who would normally be sitting or lying down for the remainder of their lives are now back up on their feet. And remember, what does this have to do with home building? I'm getting there. This is a robotics suit that's being developed by NASA. When you go up into space and you're trying to move, there's resistance that's just in the gear that you have. And so they're working on a whole system of a SMARTSUIT that will take your actions and sort of amplify them through the suit. And that's being worked on right now. So what does that mean? It means that we are designing homes right now for people that are going to be aging and for people that can't walk. And that's going to change because they're going to have the ability to stay in their 2- and 3-story home. And that's going to change quite a bit. It could change the way that we take the elderly and collect them all in nursing homes and keep them in their homes as opposed to that type of communal living. And that's going to be a huge change in the way that we keep the buildings that we have. So that's number one. Mechanization is going to change our customers as well as the way that we build. I think that we're going to move from environmental heating and cooling to task heating and cooling. And I don't know how many are familiar with the Center for the Built Environment. They are one of the leaders in research in HVAC systems as it pertains to thermal comfort. And they have developed what they call the personal comfort systems. And so the problem here is that if you try to take a building that is providing the right environmental conditions for everybody in the building, even on the best day, you can only satisfy 80% of the people because of the thermal comfort variations built into each of us, right? And so this is a half-an-hour video that, and by the way, you're going to get this presentation, and every single slide has a footnote in the slide note for exactly where I got this information. So you'll be able to take the URLs and explore this stuff on your own. But anyway, it's a great video talking about how we currently try to keep people comfortable and productive. And so the personal comfort systems are looking at ways that you take the building and drop its heating and cooling down up to 10 degrees, right? So your ambient heating and cooling drops. You make the building float, and then you provide comfort to people through these personal comfort stations. And this is driven by really accurate tracking of the number of cold and warm receptors in different parts of your body. And what that means is that if we know where people have more cold and more warm sensors, we can target the thermal comfort for those areas in a way that we can not just target people, we can target parts of their bodies that are sort of telltale for thermal comfort. So how do you do that? Well, you get people to wear like this. And this is how we know that there are certain places on your body that we can deliver cool to, and it'll keep your whole body comfortable as compared to heating your whole body or the whole building. And the other thing they've discovered as part of this research is this phenomena called alliesthesia. And so the alliesthesia principle is that people experience greater thermal comfort when there's variation in the environment rather than steady state. And so all of our mechanical engineers are trying to deliver steady state, which even on the best day only gives 80% satisfaction. And the way that you really keep people on their toes, particularly when they're working, is you have to vary the environment, because it's the changes of the environment that keep us happy and thermally comfortable. And so this is the problem, that we're shooting for these isothermal neutral environments, and actually what they have discovered is that if you change the environment, people are generally happier than in a stable environment. So the whole idea here is your feet are incredibly sensitive to particularly cold. If we have activators for very low wattage fans underneath the seat.
Is that a hot seat?
Well, not when you're moving cold air. Was that a joke? I do know that you're paying attention, Steve. So I can deliver both either heat or coolth, depending upon what's accompanying the fan movement. But here's the really interesting part. So we have 3 different cities. And so 20 degrees is about 68 degrees Fahrenheit, 22 is 72 degrees Fahrenheit, and 24 is 75 degrees Fahrenheit. And what we can do is we can create a dead band in the building, right, and deliver to individuals rather than the space. So the environmental temperature of the building goes either down in the winter or up in the summer. And you can get up to 20 to 30% savings by that. And then what you do is you heat and cool the people. And so you basically increase the dead band and then deliver the thermal comfort to the individuals. And so there's 20 years ago, we didn't have, 2-watt fans that we could use to power some of these stations. And then what you do is you hook, so you basically have hand warmers, foot warmers, and warm or cool for your face, your hands, and your feet. And then you wire them all together in an internet system. And this is being done in commercial settings. The automotive industry is working on this, but it also can be applied to residential. And so we have had task heating, right? This is a kotatsu, which is really common in Japan, that you just heat the workstation, right? So I'm convinced that if we combine the spacesuit, which is there to activate and support our muscle systems, we're going to have the same thing for heating and cooling, right? We're going to be wearing spacesuits that are delivering to those sensors And you could say, really, in 20 years? All this stuff was not available 20 years ago. All right, so you can't have a discussion about what might happen in the building industry without talking about what happens in the world at large. And so Daryl M. West is the Vice President of Innovation and Disruption at the Brookings Institution. So I don't know how many of you have strong feelings about the Brookings Institution, but I picked this guy because he grew up on a dairy farm in Indiana, went to Indiana University, now lives in Washington, D.C. If you look at his background, he is equally despised by the left and the right because he's pretty agnostic about political systems as opposed to what's happening in terms of the economy and the environment. And so he wrote a book in 2016, prior to the latest presidential election, looking at economic disruption and what's driving it. So it's a really interesting book, and I knew it was politically correct because he has spent a lot of time with both incredibly liberal people as well as incredibly conservative. So he has a chapter called Future Possibilities, and he has 5 of them. And the first one is, what if Iran gets a nuclear bomb? So does anybody know what this is? Strait of Hormuz, right? So, I don't know, 10% of the world's fossil fuel, oil, runs through here. This is Iran, right? This is all the other Arab countries. And so we've already got problems with this, right, in terms of tankers that have been held on both sides. I don't think he means just if Iran gets a nuclear bomb. I think what's even scarier is people who have cruise missiles that aren't even nuclear warheads that can lob them back and forth. Because if you think it's scary that states have this kind of capability, what if it's just groups that have this kind of capability? And so when we're talking about how our lives might change, and I know I've got to get back to home building eventually, but you can't talk about the changes in our industry if you're not talking about how fast and strong and out of nowhere these disruptions come, right? So this seems possible. The second big change that he foresees is robots taking jobs. And in this breakdown in his book, it's very interesting because he goes through and talks about, for jobs where 2% are going to be replaced by robotics. When you get to the 90%, which means in the next 20 years, 90% of the jobs will be taken over by robots, it's the service industry and the construction trades. That's where he sees the most change in terms of robotics. And then, of course, global warming and rising seas. We have surging seas risk finder here. Here we have, the next 20 years and the risk level in terms of a 6-foot sea rise. And you can see that, the possibility gets to 100% here. So, I don't really care if you believe in global warming or not, but we do know that temperatures are rising, even if we can't necessarily agree on why. And it's going to have an incredible disruptive effect. This is a map pretty close to where we are. This is Jersey City, this is Long Island, this is New York. And if you look at a 6-foot level sea rise, which is associated with, say, a 1.5 degrees Celsius, there's just all this land that is going to have to either go underwater or we're going to have to become more like Amsterdam, right? So this is a pretty cool tool because you can go in and for any place in the United States, pull up the risk zone map. And we're seeing this. We're not going to be able to build homes if this is where they're going to end up. So number 4, future possibilities, according to Daryl West, is, well, what happens if Europe turns right and undermines democracy? because we're part of a global economy, so we're really dependent on the democratic institutions in a large part of the industrialized world. But, you know, look at what's happening. The Swiss People's Party, which is, you know, a far right ultranationalist, got 29% of the vote in the last elections. Austria, Freedom Party, 26% of the vote. Danish People's Party, 21%. France National Party, 13%. And Hungary, the Fidesz National Party, won 49% of the vote. So this is potentially incredibly disruptive to the way that we do our economic systems across the globe, to which we're tied. And the last one that he covers in this book, I almost dropped the book when I got this, but he considers the 5th largest potential disruption. What if we are not alone in the universe? So Kepler 452b is one of the most recent to be discovered. It's probably about 50 light years away from Earth, but it's about 60% larger than the Earth. It's about the same distance from the same level of star, and it has a year that's 5 days longer than ours. There are over 1,000 planets now that have been identified that are considered Earth mimics, right? And the only thing that life needs is water. That's the defining ingredient. And you can think that this is off 20 years. I pulled this off the internet yesterday. So this is the chief scientist with NASA saying, we are going to find life on Mars because there is liquid water underneath some of the frozen stuff that we see at the surface. And if there's water there, we're going to find microbes. And he says, yeah, that's okay, but we're not ready for that yet. So what does that mean? It means that a lot of us, maybe all of us, that's an existential, we'll probably have to go back and talk to that robot, Jean, right? Because, Jean, what do I do if there's more than life on Earth, right? So this is incredibly disruptive to a culture and for a lot of people, religions that are totally based on us being the main point of it all. So the thing that we're going to have to struggle with is that if we have these major changes that we think have high probability, the really important question is, well, do they create common cause or chaos, right? So have we had examples where incredibly disruptive events came about, but we had common cause as opposed to chaos? Well, sure we did. I mean, think about at the end of World War I. There was no World War I, right? There was the Great War because they didn't know there was going to be a World War II, right? So it was the Great War. And at the end of the Great War, when they were doing the Treaty of Versailles, they had no idea what they were doing. There was no precedent for a world war. There was no precedent for how to move out of the end of the World War. Germany surrendered, but there were still German generals that had huge armies, right? And these guys largely, David Lloyd George from Great Britain, Woodrow Wilson from the United States, George Clemenceau from France, and Vittorio Orlando from Italy, they had to sit down and figure it out, right? So the common cause was, how do we not eviscerate Germany, but make sure that they comply with the terms under which they surrendered? They really didn't know what they were doing. So there's a great book, I think it's called, now I'm not going to remember the title, but there's a great book about how it was these individuals that were determined to figure out how to deal with a world war resolution. And the other interesting thing about this is that Woodrow Wilson was not in Europe. So part of the negotiations were done, I guess, with carrier pigeons, because did they have telegraph? I guess they had telegraphs in 1900 or 1918. But Woodrow Wilson was not convinced that he could leave safely the United States because his political position was a bit tenuous. But he ultimately decided that it was more important for him to be at the Treaty of Versailles negotiations than it was his political career. So he actually, and of course he took a boat, which took a long time. This is not a small commitment. This was a huge commitment he had to do. And so the other example is, not at the end of the war, but at the beginning of a war. This is a great book called Citizens of London that I've just been reading about how reluctant Rockefeller was to get involved in World War II. So remember, when France fell and Great Britain was by itself, there were these three men, Edward Morrow, who was the famous newspaper guy, Harriman and WINGNUT, who were working to convince Rockefeller that it was in U.S. interest to support Great Britain. Because Great Britain was being bombed to live in smithereens, while Rockefeller was trying to decide to be part of it or not. And then what finally triggered our participation in World War II? Pearl Harbor, right? So it's pretty clear Rockefeller used that to move the American people to participate in this great war. So what the point I'm trying to make here is that the difference between common cause and chaos is going to be people finding the common cause as opposed to the world devolving into chaos. I had no idea how depressing this presentation was. Sorry about that. So, what does this have to do with home building? I don't know. So, what can we possibly do? So, I'm going to start off with a couple ideas, and this will wrap it up for the night, because we're definitely going to need alcohol after this. So, one of the things we're going to have to do is, it's a really cool book because of, and by the way, I don't know how many of you know Bruce King. Bruce King lives in Marin County. He's a structural engineer who has done most of the work for the structural properties of natural materials like straw, bamboo, rammed earth, adobe. But he's a former Buddhist monk. So there aren't that many structural engineers who used to be Buddhist monks. And I asked him, I said, why aren't you a Buddhist monk? He goes, I think I did too many arm farts when we were sitting around. That, if you know Bruce King, he's pretty irreverent. But he is a very unusual engineer because he's got real serious chops on the engineering side, but he also is looking at the bigger picture at the same time, which I think is really hard to do. So his point here is that this is the embodied carbon footprint that is incurred when you build a building. And then this is what happens with the operational energy. So we're trying to deal with all of the area under this curve. So the problem is, even if we start to build net zero buildings, right, we still have this huge block, the gray block underneath here, that in the next 30 years is going to be the difference between, 600 parts per million of carbon dioxide in our air rather than, the 350 that we need to pull it down to. So Bruce's position on this is we can't just pull our operational energy down to zero. We've got to work on this part of the footprint, which is incurred in the materials that we build with. That's uplifting. So Bruce has been working, there are a couple materials you can go after if you're trying to reduce the embodied carbon of a building, and one of them is concrete. So Bruce has been working really hard from a structural engineering standpoint on how do we take the huge carbon footprint of concrete and pull it down. So this is a flow chart from his book. You can see the main culprit is Portland cement, for which we have quite a few substitutes, but it changes the structural engineering performance of the materials, so structural engineers have to work on that. You can use more carbon by using these types of aggregates. And then you can optimize the concrete in terms of sort of optimum value engineering. So in Marin County and the Great Bay Area, there are several I mean, how many of you have ever gone to a ready-mix concrete plant? Bunch of hands go up, right? Like if you were looking for the most liberal people in your town, you probably wouldn't start with the ready-mix company, right? I mean, no offense, they're great guys and gals, but so I just have this image in my head of Bruce King, a former arm-farting Buddhist monk, going into Central Concrete and saying, hey, I'm Bruce King, I'm a licensed professional engineer. You need to change the environmental footprint of your concrete in your ready-mix operations, right? Well, you can imagine how that went, right? Well, it turns out Central Concrete has, if you go to their website, a whole system of reducing the impact of concrete using the flow chart that Bruce King built and they are now using, including on their website a mix selector that allows any architect or engineer to go in and dial the different environmental impacts of all the materials in concrete to pull it down. So they know what mix to use. Now you can imagine if you go to a ready-mix plant, they only have one bin for Portland cement. If you're going to have Portland cement substitutes, you're going to have like 5 bins. So this is complicated engineering that we need to do to decrease the environmental footprint of the concrete. But it's being done. Why? Because Bruce walked in as a structural engineer Buddhist monk to Central Concrete and convinced them that this is what they should do. And actually, it's part of their business model now. They are getting spec'd more in the Bay Area because of their environmental emphasis. The other thing I think that we're going to have to change is design for disassembly. Now here's the thing. Every single weather-resistant barrier and air barrier that we build is dependent on sticky stuff. And sticky stuff makes it harder to take things apart. So we have this tension between high-performance buildings from a hygrothermal perspective and design for disassembly. So Steve is one of my favorite architects in no small part because I've seen Steve just take something like, okay, I'm a builder in the Southwest, and my #1 complaint from my customers is I can't get hot water in my master bath. Why is that? Well, because every home built in New Mexico is on a slab, and that means all the piping's in the slab, and they've tried insulating it, and then the concrete guys come in and they rip the shit out of all the insulation around there, and they just cannot get hot water through that slab. So the head of the company Steve was working for said, you now have to build all the homes with no longer than a 20-foot run from the water heater in the garage to any draw. So what does Steve say? Steve said, that's just a design constraint. If you tell me that's what I have to do, I'll just give you a whole bunch of designs where everything is less than 20 foot in run. Now, most architects would just say, what are you, crazy? I need to put stuff all over the place. I'm always going to have runs longer than 20 feet, but it's a design constraint. So now what we have to add is a new design constraint, because if we design for disassembly, we can take that huge environmental gray box, right, the embodied energy, and if you take that sunk cost and you move it into the next building, you're protecting that embodied carbon investment. And by the way, Bradley Guy is a professor at Catholic University who is sort of largely responsible for a lot of the early work that was done. This is also sometimes called design for deconstruction. And there's a manual for design for deconstruction. There's a Chartwell School out in California that was built as an early case study. And interestingly, they picked structurally insulated panels for the roof system. Now, wait a minute. There's a lot of sticky stuff that made that SIP panel, right? Well, it's the panel that you take apart, right? And reuse that. So you can use sticky stuff. You just have to have a way of putting those panels together in a way that you can deconstruct them. Well, that just takes care of the new buildings. We have way more existing buildings than we ever make. We have like 115 million existing dwelling units, and we build 1.5 million each year. So the 800-pound gorilla in the room is not new construction, it's renovation, right? And so in Bruce's diagram, well, look, if the environmental footprint of an existing building is smaller and it's sunk, right? It's gone, right? If I have a big church that's made out of concrete pillars, and there's a lot of embodied energy in them, well, that incurred a long time ago. It doesn't count as a sunk cost, right? So if we take those buildings and we drag them kicking and screaming and reduce their operational footprint, we've avoided this portion of the box. So the big impact that we can have is by improving our existing building stock, not just, we can't build our way out of this, we can renovate our way out of this. So, I wrote a blog for Green Building Advisor a couple weeks ago because AEROBARRIER is this new aerosol system, and they don't say that their franchisees can use their product system on existing buildings, but they're doing it anyway. And there's a guy in Utah who not only does AEROBARRIER on existing buildings, he does it on occupied buildings, right? So think about it. We need to make, if 25 to 40% of the energy in a building is air leakage, and we've got all these really old leaky buildings, what if we could, in 3 hours, take them from 14 ACH50 to 3, right? And all you got to do is tape everything off. You're like, how the hell do you do that? Well, the guy in Utah, he doesn't do it. He has a high-end painting firm, and they tape off everything anyway when they go inside of a building. So they go in, they take everything out of the closet, they dump it on the bed, and they wrap the bed. They go in and they pull back the carpets, right? Installed carpet, 3 hours. They're done. 3 hours, AEROBARRIER comes in. 6 hours later, you've got a home that went from a complete dog to one of the hardest things, which is, you know, I have a 110-year-old house in Brattleboro. And I don't know what the ACH50 was when we started, but it was definitely above 10. And doing all the work myself, piecemeal, room by room over 12 years, I'm at 4 ACH50. And when Betsy Pettit for Nessie did like 12 different projects in New England that were all room by room retrofits, no one got below 4 ACH50. The only way they got below that to 1 ACH50 was if they jacketed it from the outside, right? Well, this is going from the inside, right? And then we've got AEROGEL. So this is a patent that Miguel Gonzalez pulled from TAMLYN for an R12 AEROGEL house wrap. Right? So AEROGEL is when you make the spaces between the insulation material so tiny that you can get R10 in about 3/8 of an inch. And they call it frozen smoke. The air pockets are so incredibly tiny that that's the way you get the R value in that thin of a layer. And so where is all the AEROGEL going? It's incredibly expensive, but what's driving up the price of AEROGEL? Well, every pipeline in a cold climate, the way that we keep it warm is we wrap it in AEROGEL. So all of the AEROGEL that's being produced is going into the fossil fuel industry right now. So Miguel is waiting for the production of AEROGEL to go up or the oil industry to crash so that there's enough available for him to make this, because he's already pulled the patent. And we already have Aspen Aerogels, Thermoblock. These are companies that are making insulation. These two technologies paired up in existing buildings could completely change the performance of those 115 million units that we have that are currently energy dogs, but that can become high performance. So I'm going to end with this, which is there's a great paper by Jennifer Thorne Ammon. This is from ACEEE. It's a big energy efficiency conference. It's held out in California every like three years or so. And she wrote a paper called Energy Codes for Ultra-Low Buildings. a critical pathway to zero net energy buildings. And I wanted to show you this graph. So this is what's going to happen in the next 10 years from now. This was back in 2014 when she wrote the paper. And there's two main things that are going to happen in our codes. The first thing is that we're going to have to move to performance-based pathways. The second thing is, look what happens down here. There is no way that we're going to make really high-performance buildings without some serious training all the way across the industry, including building inspectors, right? And so I think the last thing that's going to change between now and 2039 is we're going to have to make sure that it's not just 200 people that come to the Fine Homebuilding Summit that understand how buildings work and how to make them perform ever better. It's going to have to be everyone coming to the table. And that's that common cause versus chaos, right? And one of the ways to look at this is, while you're here for the next 2 days, we have a small group in Brattleboro called Sion. I gave a 2-day building science training, and you know, these are all my friends and neighbors. They were so pissed off at me at the end of 2 days. Like, I went home last night, I can't do anything because I know that everything I do is wrong. So we formed a builder guild, and it meets once a month for 3 hours, and there are 4 rules. So the first rule is check your business at the door. Who is possibly going to air their dirty laundry if you don't do that? That's rule number 1. Rule number 2, your competition is not the people in the room. Your competition is all the people who aren't in the room. Rule number 3 is from Sam Levinson, journalist from the 1930s, who said, no one can ever live long enough possibly to make all the mistakes themselves. You must learn from the mistakes of others. And then the fourth rule is there always has to be alcohol at the Builder Guild meeting. But if we don't do this, then we're going to have chaos rather than common cause. And with that, this is my mother, who is 98 last month. These are my daughters. They're now 21 and 18. But it's our generation that has sort of spent the fossil fuel bounty. And my mother grew up during the Depression. She knows about common cause and working for the greater good, right? Because that's what we all did during the Depression. And I think my daughters are going to experience the same thing. It's because of our generation's approach to the fossil fuel bounty. So we have a responsibility to do what we can within the building industry, and we're going to do that with a lot of technology, but also a lot of hard work and common cause. Thank you.